Okay, today is March the 30th, 2017, and right now at 9:55 p.m., we've got a temperature of 55 degrees here in the foothills of Los Angeles. The relative humidity is down, it was down at 22% here about an hour ago. And right around 9 o'clock, it was about 21, 22%. Right now it's 33%, so it's gone up quite a bit. We have a barometer reading. It's dropped quite a bit. We've got 29.85 inches on the barometer, and that's because of this low pressure system passing right over Las Vegas. This has sort of been moving in a southeast direction, and there's high pressure adjacent to this. We're going to show some very interesting shots here. We've got a high pressure installed. We can see the outflow right here in the IR map, and that is causing a lot of wind right here in the Southern California area. Right now we have winds gusting up to 50 miles per hour. It's not a consistent wind. It calms down, and then we have a big gust, and it's kind of like that. It's not a steady windstorm like we've had years ago. All right, so we've got a dew point of 27 degrees, and we had puffy clouds in the skies earlier today, and it was rather interesting weather. It looked like it could have rained, but there was also these dissipating chemtrails being sprayed in the skies today, and all the way up into the evening hours. We saw the short dissipating type chemtrails, and then the wind picked up right around, I think it was right around 6:30, somewhere, I think it was right around 6 or 6:30 p.m. The wind really started to pick up, and so that's where we are right now. We have interesting situation here. Let's look at these maps. Let's go to the water vapor map right now for the western U.S. We have this giant low pressure system right here, which is not producing any rain here on the west side. If we go to the Doppler map right now, we can see the situation with the precipitation right over Las Vegas. We had some heavy rain earlier today. We can see some snow and rain near Flagstaff. And there's a little bit of rain out here in the eastern desert area, Mojave Desert, and some snow indicated along the Sierra. All right, so let's go back and take a look at the let's take a close-up right now of what's going on here with this storm system. And I'm going to stop this, and we'll take a look at the transmitter activity right on the center of this storm. You can see these angles right here, these rectangles. Let me get this thing queued up right. All right, so we see some manipulation right in here. Straight edges, oblique angles. That's a very straight edge right here and here. Got a straight edge here. And of course, the visible light map is corrupted during times of high importance. This is typical. We see the maps are corrupted. We can't see every frame. All right, let's go to the big map. And we have jet stream flow right here, which is running into this blockade. This is a transmitter generated blockade, preventing this moisture field from running right into that low pressure system. And of course, high pressure flows to low pressure, so we have a blockade here to prevent, like I say, from this merging with that system. And that is going to, this is generating a lot of wind. We've got high pressure on this side of the, on the west side of this storm, which is spinning clockwise, and we have counterclockwise activity here. And all that wind is shooting right down towards us right now, Southern California. So we've got a lot of wind all over the area. all the way out into the desert areas, all the way to the ocean, out into San Bernardino, and here up in the foothills, all along the foothill communities, we've got wind, strong wind. And of course, that is because of this man-made high-pressure system here, which is preventing this system from developing now. As this moves away, this is going to really develop into something big, because they'll pull the transmitters off, just like we saw on this last system, which has moved further east. We had all that tornado activity over Texas, and that was from last, we remember here just a couple of days ago, we were watching that. That system was over California as well, dropped no rain last weekend, and then it moved away. They pulled the transmitter off, let it spool up, and then we had all this wild weather. Pardon me. Last couple of days ago here in Texas. So this is going to be a rerun of that, and we can see the manipulation going on here. We have jet stream flow walling up into this high pressure zone, this blockade, and this has nowhere to go. We can see the clockwise rotation right here, where all this high pressure is installed. Now, if we go to the IR map, we can see all that outflow, where this descending air is forcing the weather controllers are forcing descending air into this area, and that is maintaining this blockade, this wide channel right here. Now, the other thing I wanted to point out is this very, very straight edge over here. Let's go back to the Northeast Pacific Rainbow Loop. Up here near Alaska, we have a storm system, and we have a very straight edge here. Let me get my envelope out here. All right. Let's go ahead and pause this. We have a very straight edge right here forming right there. This is a right angle right here. I don't know if you can all see that, but this is a very, very long straight edge. This area from here to here extends from Washington all the way down to Mexican border. We can see how straight that is. And we have a partial right angle. It's difficult to see, but right here is a better shot. And, an idea of just how straight that is. It's a 90-degree angle right there. Of course, this is generated by a phased array transmitter. Phased array transmitter, which is probably microwave, and this is peeling away this frontal system. This will split this frontal system away from the center. Let's run the loop and see what happens here. We can see all that clockwise rotation right here, and that's exactly what this is engineered to do, is to split this frontal system away from the center. Now, if we look at this in the water vapor map, it's not quite as apparent, that right angle, but there is this very straight edge right here. We can see that. And on the surface analysis map, this is around a 968 millibar low pressure system. Let's go ahead and look at that right now. 964 millibar. There's actually two lows, 966 and 964 right here, and these are moving up towards Alaska. And this is indicated as a storm. It's a trough right here, and that's a storm system. Okay, so then we have high pressure depicted out here, and this is right next to that low. This is not really accurately depicted. The center of this high is way over here, right up against that low pressure system. They're actually hitting the center of that storm very heavily with a power, and we can see that right here. Right here, all of these angles, you can see that right angle right there. Moves around counterclockwise. So they are pulsing power on this. It's not obvious what they're doing until you freeze frame it and just step through, and you can see these oblique angles, straight edges, like what we're seeing right here. This should be a tight spiral like you'd see on a seashell, like most storms. Everything now is manipulated. Okay, let's take a look at the swell report. And we have 21-foot seas being generated by that system offshore from California. This storm, which is moving up towards Alaska, 21 feet. We have 12 and 15-foot swells moving right into central and southern California. And here's the jet stream map. You see the flow is moving right into that. There's that barrier, that blockade that's been built in to shield this low from the jet stream. Everything is having to detour down and around. Actually, all that water vapor is being completely evaporated. If we go back once again and look at this, we can see what's happening, the effect that transmitter generated blockade is having. All this water vapor is just evaporating right in here. We still have high speed flow moving in, but we've got that transmitter activity going on here. We have all this clockwise rotation, and that's causing the wind. All right, let's look at the pressure maps. We have the sea level pressure right here. You see a lot of squiggly lines around this low. That's transmitter manipulation. See the varying degrees of high and low pressure all mixed together here. And we have that we have a surface low out here heading up towards Alaska. That storm system, 968 millibar, they're showing right there. 500 millibar, we have a closed low right here over Las Vegas, Nevada. Got high pressure right in here. And we've got this big low pressure system up here, two lows actually. And now the 300 millibar map. See that closed low right there, storm system. As this moves away, this will rebuild and bring some real bad conditions to the states out to the east, and that's what have to keep an eye on that. It's too bad they won't let it rain here in Southern California. This is the current Doppler map. There's not much rain. We're getting rain out in Arizona and Nevada and Utah, Colorado. Okay, so that's the report for today. And we'll just leave it right. Also, here's the visible light map. We can see some activity right here, right there. Looks like they're hitting this with microwave. Of course they are, and you can see it right there. Okay. All right. Well, that's it. We'll do another update tomorrow.